Hey Santa.
Hey Carl, how are you doing?
Good, I just want to show you some of the results from previous years.
Okay, what type of results are you talking about?
These are the amounts of teddy bears that have been wanted over the past 15 years. As you can see, the amount of teddy bears wanted each year is increasing.
That sounds good. Keep up the work so we can make all the kids happy this year.
When I added up the numbers from previous years and divided by 15, I found out that on average 88 teddy bears were wanted throughout. Then we have the median and mode. I put all the numbers from least to greatest and the most occurring was 93. Then I found that the middle was 93 also.
Excellent work, Carl. We should start keeping track of this data.
Santa, I have this right here. It's a stem and leaf plot.
What's a stem and leaf plot?
This is a stem and leaf plot. It is a way to organize a set of numbers. The stem is a set of vertical numbers and the leaves are the horizontal numbers. Each number on the stem represents a multiple of 10 and each leaf is a number of units. For example, right here, this number is 72.
That's great, Carl. Thank you for all your hard work.
Hey Carl, how you doing?
I'm good, Claire. How's the work coming?
It's great, but I was wondering, what kind of presents do the kids want this year?
Well, Claire, I'm really glad you've asked. I've been doing some research and have found out that a lot of kids want Barbies this year, based on the wish lists that they have been giving Santa. This means that the workshop elves are going to need to increase the production of Barbies in order to meet the wishes of all the kids around the world.
Wow, Carl, that's some very interesting stuff.
Oh, and I've also made this pie chart to show the percentage of gifts wanted. As you can see, 38% of kids want Barbies, but only 3% want roller skates.
Wow, 38%? That's a lot. Me and the other elves really need to pick up the pace on Barbies so we can make enough in time for Christmas. I should also let them know we can slow down on roller skates. I'll go tell them right now.
Okay, Claire, that's great. Thanks for being such a hardworking elf. See you later. So Santa, since I have been making so many charts and diagrams lately, I figured why not make one more?
Wow, Carl, you've been helping me out so much in the past couple of days. I'm so glad to have an elf like you.
Thanks so much, Santa.
Okay, so what were you going to tell me?
I found out from Claire the amount of toys that have been made each day in the past 15 days. These were the numbers: 69, 72, 86, 95, 97, 102, 103, 110, 117, 126, 131, 137, 148, 156, and 162.
Okay, Carl, so where are you going with this?
In order to make a box and whisker plot, you have to find a 5-number summary, including the minimum, first quartile, median, third quartile, and maximum.
Okay, so how do you do that?
First, you put all the numbers in order from least to greatest. Then, the minimum is the smallest number, the maximum is the largest number, the median is the very middle, the quartile 1 is the median of the bottom half, and the median of the top half is quartile 3.
Okay, so based on these numbers, what are they?
The smallest number is 69, so that's the minimum. The first quartile is 95, the median is 110, the third quartile is 137, and the maximum is 162.
Alright, so have we made a box and whisker plot?
No, now we have to graph it. You take a number line, and above each of the numbers included in the 5-number summary, you plot the points. Then form a box around the first quartile, median, and third quartile with a line through the median. Then connect the minimum and maximum to the box.
Wow, that's cool. It looks good.
Okay, so this means 50% of the days we make more than 110 toys.
That's good, but we need to make sure that every day while Christmas we make above 110 because we need to have enough toys for Christmas.
Okay, I'll be sure to tell Claire and the rest of the elves so that we can really buckle down and focus in the workshop.
Sounds perfect.
Hey Jack, haven't seen you in a while.
Yep, it's been pretty busy around here nowadays.
Well, I've got to ask you about the quality of some of these gifts.
Yeah? So what about?
Well, some of these toys we've been making are pretty bad.
I agree. Some of these toys look like they're in no shape to give to little boys and girls for Christmas.
I think we need to start making a standard for the quality of our gifts.
Okay, well, the quality of the gifts are normally distributed between 0% and 100% quality.
And what is normal distribution again?
Normal distribution is a bell-shaped curved line that is a best fit on a set of data.
Well, how do we know if our data is normally distributed?
Well, Claire, if you look at this graph, it is normally distributed. You can tell this is true because the mean is equal to the median. The graph is symmetrical about the y-axis. Also, as you can see, there are more points closer to the middle and fewer points towards the left and right ends.
That sounds like it is a good way of telling how good or how bad the quality of each of the toys are.
Yeah, it is. We should use the normal distribution scale more often.
Yes, we should. You know, I was chatting with Santa the other day and he was talking about the same thing. He said we are starting to make some unacceptable toys.
Well, maybe we can make a certain standard that all the gifts have to make.
Oh yeah, so we should trash the bottom 30% of quality or something.
That's good, but how in the world are we going to find that out?
So if you take the qualities of these gifts, 45, 51, 55, 59, 63, 78, 79, 85, 87, 90, 93, 95, 98, and 100. First you have to find the mean.
Okay, so add up all of the numbers up, which is 1,177, and then divide by 15, so the mean is 78.5.
Next you have to find the standard deviation.
Okay, so that is 18.3.
Sounds good. Okay, so there is this formula that says z-score equals x minus mean divided by standard deviation. We know the mean and the standard deviation, but not the x or the z-score. So because we want to trash the bottom 30%, you use this chart and find 30%. From here, you can tell the z-score is negative 0.525. So you have to plug it into the equation. So negative 0.525 equals x minus 78.5 divided by 18.3 and solve for x. You multiply both sides by 18.3, then add 78.5 on both sides, and you get that 68.9 equals x.
So based on these numbers, anything below 68.9 in quality has to be thrown away.
Yep, I guess that means we have to throw away these presents.
And I will go tell the elves we need to bump up the quality.
Okay, see you soon.
Ho, ho, ho! It's almost time for Christmas.
But wait, Santa, we still have to feed the reindeer.
Yeah, I learned something in elf school that can connect with how to feed the reindeer, and it's called standard deviation.
Wait, what is that?
Standard deviation is an important measure of how our data is spread out. This practically means how much, on average, the data will vary from the mean.
That's very good, Claire.
Yeah, tell us more. Like, how do we find the standard deviation?
Well, first you have to find the mean of all the numbers.
Okay, that's easy. You just add up all the scores and then divide by the number of scores we have.
Right, then we have to find the amount each value varies from the mean, and also add all those scores up to find its total.
Okay, so how do we do that?
Well, Jack, you need to use the equation x minus mean squared to each of our numbers or scores to find the total amount each score varies from the mean. Then you divide the number of scores by the total that you just got. And once you have that equation, all you need to do now is take the square root of all the whole thing.
Wow, I'm glad you're learning so much in elf school.
Thanks, Anna.
Okay, Claire, so what does this have to do with feeding carrots to reindeer?
Well, Santa, I'm glad you asked. If you add all the number of carrots each reindeer needs and divide it by the number of reindeers, which is 8, and get the mean of 6.13.
So then to find the standard deviation of our data, you take the number of carrots and subtract it by the mean from it while squaring it. Then use the square root over the whole equation and divide by 8.
Next, you simplify the equation, square root of 24.8752 divided by 8. Then solve that and you get 1.76, which is the standard deviation.
Okay, I get it. So if you add and subtract the standard deviation to the mean, you get 4.3 and 7.9. That is the standard range of the amount of carrots the reindeers need to eat. So if they are above that, they're eating too much. And if they're below it, they're eating too little.
Thanks for all your help, guys. Ho, ho, ho. Merry Christmas!